Okay, thank you. Wait for a minute. So now is it clearly audible? So let us start with the questions. So actually previously we started about the SQL, and within that we have studied about the few of the keys. So we studied about the keys of the relation. So within that we have studied about the candidate key, super key, primary key and alternate keys, and foreign key. So these concepts we have learned. So within that, let us revise what we have studied already. So we have studied about the candidate key, the minimal set of attributes which can determine a tuple or a record uniquely. So that will be called as a candidate key. So this can be a single attribute or it can be a set of attributes. So the key, this concept refers that I should not have a repetition of the values and I should have a mandatory value. It should not have a null value. So this is a candidate key and the set of attributes which can determine the tuple uniquely plus the superset of those attributes is called as a super key. Then primary key we studied, that is among the various candidates. One key is taken as a primary key and remaining will be called as a alternate key. And next we uh, studied about the foreign key. So foreign key is set of attributes which is used to refer to a primary key or alternate key of same or another table. That is, here we are taking a reference of some another attributes into a table. Just like for this purpose, we have taken example of that is bank accounts and ID of the employee being referred into some another table. So okay, so it means that I should have a validity of the value. So here we are checking the constraint of referential integrity. Okay, so now after that, uh, I wanted to cover for normal forms. So let us revise first definition. So it means for this purpose, we will revise the definition and then we will move to the example towards the no, SQL and then normalization. So first normal form. So first normal form, it means that any attribute within my relation should not be composite attribute. It should be a simple attribute that is atomic in nature. That is the if all the attributes are atomic in nature, then I can say that relation is in first normal form. So here it doesn't refer to only composite attributes. I should not have a multi-valued attribute as well. For example, if I'm considering that, so instead of this, I will take here. If consider I'm having roll number of the student, okay, roll number of the student, I'm having name of the student, and consider phone number of the student. Okay, so these are the, or instead of phone number, I will use the term contact number. Okay, so these are the three attributes of my relation. Consider. So now, if I'm considering the roll number, I cannot divide the roll number into sub parts. Okay, that's why the roll number will be always a indivisible unit. Whereas, if I'm talking about the name can have its first name, middle name, and last name. So these can be the parts or subparts of my name. So it means that name is not a simple attribute. So this is not atomic in nature. Atomic in nature, it means that whenever I'm referring this as a non-divisible unit. Okay, so that's why the atomic, this word is divided. Atomic means that the indivisible smallest unit, the same we are referring here. So, and when it comes to the contact number, if consider that I'm having contact number 1, or I can have another contact, it means multiple points of contact can be there. For example, someone might use dual SIM, some another contact for the WhatsApp number, some another business account, or some normal calling account, normal calling number, etc. It means that a person can have more than one contact number. So this will be called as a multi-valued attribute. This will be called as a composite attribute, and the attribute which I'm unable to divide into the subparts, so that will be called as a simple attribute. Okay, so it means that here out of this only roll number is atomic in nature, whereas these two are not in atomic in nature, and that's why I need to convert this relation into some another schema so that I can say that all the columns should be in atomic nature. The first normal form says the same thing. A relation is in first normal form if it does not contain any multi-valued or composite attribute. That is, all the attributes should be simple attribute, atomic in nature. Next, second normal form. A relation is in second normal form if it does not contain any partial dependency. Okay, so partial dependency, it means that here, if consider right now, we have taken that is multiple schemas we have studied. So consider that attribute A1 and A2. Combinedly, these forms my primary key. Okay, or instead of key, I will take this as a primary key. Okay, so these two are my these two combinedly forms my primary key. It means that these two becomes my composite primary key. Okay, and consider other than this, there are other attributes like A3, A4, A5 are there. So the partial key dependency says that the whatever other attributes are there, A3, A4, A5, these all should be dependent on A1 and A2 combinedly. It should not happen that A3 is only dependent on the A1. Okay, so this should not be the case. Partial key dependency म्हणजे माझ्या complete कीवर dependency हवी remaining attributes ची. हे complete attributes एखाद्या कुठल्या म्हणजे partial म्हणजे ह्या दोघांपैकी partial attributes वर dependent आहेत अशी केस नसावी. Either dependent on either A1 or A2. That should not be the case. It should be completely dependent on these three attributes should be combinedly dependent on these two attributes. Partial key dependency should not be there. So if a relation is in second normal form if it does not contain any partial dependency. A dependency is called a partial dependency if any proper subset of the candidate key. Okay, proper subset, it means माझ्याकडे दोन की आहे त्याचा कुठलाही proper subset determines non-prime, that is other attributes which are not part of candidate key attributes. Okay, so whenever I'm talking about this example, the subset of my primary key determines the non-prime. So this becomes my prime attribute which comes under primary key, and remaining attributes becomes my non-prime attribute. So if either of the attribute is dependent on the subset, then this kind of concept is called as a partial key dependency. So that should not be available into my relation. The next third normal form. So third normal form says that there should not be any transitive dependency. Transitive dependency, for example, if I'm having A4 dependent on A3 and A5 dependent on my A5, then This means that, so this gives the indication that my A5 is dependent on the A3. So this transitive, that RHS of one dependency should not be the LHS for some another dependency. And that's why such transitive dependency should not be there into my relation. For the relation to be third normal form. So third normal form, a relation is in third normal form if it does not contain any transitive dependency for a relation to be third normal form. Either LHS of functional dependency should be super key or RHS should be the prime attribute. Okay. So this is the, it means another indication when I can say that relation is in third normal form. And then bias code normal form. So bias code normal form says that every LHS should be my super key. Every LHS, that is left hand side of my dependency, should be my super key. So then I can say that the relation is in third normal, sorry, bias code normal form. So the relationship between normal forms can be represented. So this is the relationship that all the relations which are in BCNF, I can say that those all will be in third normal form. All the third normal form relations are subpart of the second normal form relations, and all the second normal form relations are also in first normal form as well. So please, all of you, I request you to read this complete slide for a minute, and then we will go for few of the signs of the relational algebra, and then we will start with the example. So please go through this reading for a minute.
Okay, Sana. Let us go for the next signs of the relational algebra. So in the relational algebra, there are multiple symbols are used. So this is one of the procedural languages which is having basic as well as the extended operators. So let us see which are the operators and for which purpose these operators are used. So first is a sigma. So right now we are dealing with the basic operators, that is a sigma. So which stands for the selection. Selection, it means that right now, if I'm having a complete relation, from that relation, which records I'm willing to uh, take or which records we are willing to select. So here selection is a row based selection. So we are passing condition on the rows, which rows or which record should be selected. Okay, so this is used to filter the rows from the relation. So right now we are talking about the relational algebra. Next sign is pi. So pi is used for the projection. Projection, it means that out of all the columns, which columns we are interested to display. So for the display, that is for filtering the columns, we are using the pi symbol. Next one is a cross. So cross is used for, that is cross product between the two relations. Two relations, it means that the every record of my one relation will be get mapped with the every other record from the second relation. And for this purpose, cross sign is used. Similarly, next sign is union. So union, it means that, so this is just like a union of two sets. So query 1 and query 2, the output of these two queries combinedly will be presented. So union, this is one of the set operations. If I'm having R1 and R2, then the R1 and R2 combinedly, the union of these two will be given as a result. Next, minus sign. So if I'm saying R1, the relation 1 minus relation 2, so it means that all those records from the R1 which are there in the R2 will be deducted. Okay, and this is again a binary operation. So here all the records which are common between R1 and R2, those all the records from R1 will be get eliminated, and only the records which are there with only R1, those will be displayed here. And last one is row. So row, this is used for the renaming a relation to some another relation. So this takes the new name for the relation. So here into the new relation, again we can go for renaming a column or attributes as well. Okay, so these are the basic operations the relational algebra is providing. So now let us go for the first question, that is question 1. So give two relations, what will be the maximum number of the tuples after natural join? Okay, so how we can answer this question? So for this purpose, let us see what is meant by a natural join operation. Okay, so first, if consider I'm having R1 relation. Okay, so consider that there are 50 tuples are there, or let us take this, this is having 200 or 100 records. Another relation R2 is there, which is having consider 50 records. Okay, so natural join says that if I'm saying R1 natural join R2, so it means that this will check which are the attributes common between R1 and R2. Okay, R1, this is one relation, and R2 is my another relation. So whenever we are performing the natural join, so this will go for equivalence join. Okay, equivalence join between the common attributes between the both relations. Okay, for example, consider that this R1 is having four attributes, A1, A2, A3 and A4. Okay, consider these are the attributes of my first relation. And second relation is there where I'm having attributes like A1, A2 and consider A5. These are the attributes of second relation. So the natural join says that it will combine only those rows into the output wherever I'm having R1 dot A1, that is attribute 1 from the first relation equivalent to R2 dot A1. Okay, the first attribute should be matching, and not this is the only condition. So it also says that wherever there are common attributes are there. Right now there are two attributes which are common between the both relations. Okay, so at this point it should have equivalence for all the attributes. Okay, म्हणजे समजा दोन रिलेशन्स मध्ये जेवढे जेवढे अट्रिब्यूट्स माझे कॉमन आहेत तेवढ्या सगळ्या अट्रिब्यूट्सच्या व्हॅल्यू जर इक्वल आल्या तरच माझं ते आउटपुट नॅचरल जॉइन मध्ये कंबाईन होतं, म्हणजे नॅचरल जॉइन मध्ये येतं. If consider the first condition is satisfied and second is not, then that row or that record is not taken for the output. Okay, and in the output I will have first the all the records or all the columns. आधी पहिल्यांदा common column येणार. A1 A2 दोन्ही पण relations मध्ये combine आहेत, so it will have A1 A2, then remaining attributes of the first relation, because here this is my left relation and this is my right relation, so it will have all the attributes from the first relation along with the common attributes, and then it will list the remaining attributes of the second relation as well. Okay, so now this A5 will be from the second relation. Already A1 and A2 is already there. So this will check whether this condition is satisfying, then only this will add this output to the result. If not, either this is satisfying or this is satisfying, so this will not be added to the output, and that's why natural join is always called as the equivalence join. And consider within here I'm having only one attribute common between the both, then only this much condition will be checked whether it is true. If so, then those all tuples which are satisfying this condition will be qualified to become the part of my output. So this is how the natural join works. So now let us come to our case. That is, I'm having 100 records into the R1 and there are 50 records available into the R2. Okay, so here in the worst case we can say that right now A1 and A1. Okay, this is A1 and this is A1. So these both are the primary keys of my relation. Okay, primary key आहेत दोन्ही पण relationच्या. It means that I will have different 100 values for the R1 and R2. This will have the 50 different values of my A1. So what can be the minimum number of records we can say, or maximum number of the records? Any idea? Okay, let us read the question once more. Consider the following relation R, A, B, C. That is, relation R is having A, B, and C. These three attributes, and another relation S, which gives B and D, B, D, E with underlined primary keys. Okay, underlined primary keys here within the R. I will have B as my primary key, and in the S, I will have BD as my primary key. The relation R contains 200 tuples. And the relation S contains 100 tuples. Okay, so what can be the maximum number of the tuples in the natural join between R and S? Okay, so here they have taken example of the 200 and 100. So R contains 100 and S contains 100. So I will change my numbers. This is containing 200 and this one is containing 100. So here A, B, C. So I will rename this A, B, and C. And here I'm having B, D and E. Okay, so this one is my primary key and this two becomes my primary key. Okay, so now let me know what can be the how many maximum tuples can be there here. Any idea? I need to check for this condition. R1 dot B should be equal to R2 dot B because B is the only attribute common between them. So what can be the maximum and minimum number of the records? Any idea? So here the first question, B is my primary key. It means that whatever this 200 values will be there, those will be different. It means each value will be unique. So now you can check whether how this 200 value case can change with this 100 values case. म्हणजे मला असं म्हणायचं की त्या 200चं आणि ह्या 100चं जर कंपॅरिझन झालं तर काय काय पॉसिबिलिटी असू शकते. म्हणजे 200च्या 200 माझ्या 100 मध्ये येऊ शकत नाहीत. Or these 100 values which are available into R2 can be part of this 200 values. Or whether here the repetition can be there. Of course, here as this is a key, so here a repetition will not be there. Different 200 values of B can be there. So what can be the maximum and minimum number of the records satisfying or can be the output into the natural join? Can anybody answer this question? So you have 2 minutes. Okay. So here, uh, let us consider that. Let us take scenario one by one. Okay, the first case is that here I'm having 200 values and here B is my primary key. It means that different 200 values will be there. The first case is that, okay, the first case that whatever these 200 values are there, B is my foreign key here, and whatever this 100 values are there, all these 100 values are from these 200 only. Okay, so being a foreign key, it means that all these hundreds values which I'm having into R2 are from this 200 only, and because of which every value which is available into the R2 is my available into this value as well, and hence natural join will say that this B and this B is same, and because of which the maximum number of the tuples will be 100 here. So you might be thinking why there should be 100. Maximum it means that की म्हणजे बाबा जे काय 100 आहे तिथं ते each one might be different, may not be different. म्हणजे इथं B आणि D combinedly माझे primary key आहे. So it means that there can be value repetition between B as well. म्हणजे असं असू शकतं की B आणि D चं कॉम्बिनेशन माझं प्रायमरी की आहे. याचा अर्थ फक्त B इंडिपेंडेंट आहे किंवा युनिक आहे असं मी गॅरंटेड करू शकत नाही. Even though if we are guaranteed, we are considering that there are 100 values and 100 of those values are unique, and that's why I can say that the maximum इक्वलन्स म्हणजे मॅक्सिमम व्हॅल्यूचं मॅचिंग झालं ते 100 असू शकतं. मॅक्स here I'm saying that a max word can be there. So it might happen that here is some value 200. This might get repeated here twice. म्हणजे असं असू शकतं की ती व्हॅल्यू इथे दोनदा आलेली आहे आणि D ची व्हॅल्यू सेपरेट आहे and that combinedly forms my key. So it means that here माझे comparison 100 पेक्षा कमीवर सुद्धा येऊ शकतं. So it means 100 is my max value where I can have the matching between these two values. इथली एक व्हॅल्यू इथल्या दोन व्हॅल्यू सोबत मॅच करते. That cannot be a case because here already we are stating that B is my primary key into the given relation. As the underlined word was key, underlined letter attribute was a key attribute, and that's why I can say that B is my key attribute, and hence there is no chance that a single value from R2 is also repeated for multiple times into R1. No, here B's value is unique, and that's why we can say that max 100 comparisons can equalize, or 100 comparisons equal येऊ शकतात, or the number can be less than that. Another case is that there is no relation between this B and this BD, and because of which I cannot guarantee that this B is my foreign key here. Okay, म्हणजे B माझी ही foreign key आहे, याचं काहीच लॉजिक नाही. So this is having a separate combination and this is having a separate combination. So let us see which other combinations can be there. Or for example, here if I'm having 200 values, so I can say that consider B's value is running from 1 to 200. Okay, B ची व्हॅल्यू माझी 1 पासून ते 200 पर्यंत आहे. And here in case of this, if consider I'm having B's value available here from 201. It means other than 1 to 200 I can have every possible combination. Repeat असू शकतं किंवा तीच व्हॅल्यू किंवा एक सुद्धा मॅचिंग नाही झालं. So minimum number of the records I can say that there are 0 number of the matchings are there, and that's why there can be 0 tuples or 0 records will be there into the natural join. So first case is that here I'm having B and D as a part of primary key, because of which even though if I'm saying that this value is not getting repeated into the B, this might value get repeated here, and the maximum number of the matchings will be 100. And if I'm having every value different from this B to this B, then we can have zero number of the records, or zero is the minimum number of the records. So how to solve? So this is my explanation. So let us go for the written explanation. To solve this type of the question, first we will see on which attribute the natural join will take place. Okay, so natural join selects those rows which have equal values for the common attribute. In this case, the expression would be like, so here the expression is given that on the cross product, B is the common attribute between the both. So selection will be made whether R dot B equal to S dot B is there. Okay. In relation R, B is a primary key. So the relation R will have 200 distinct values of B. On the other hand, relation S has BD as a primary key. So attribute B can have 100 distinct values or one value for all the rows. So this might be there. So this is a scenario, that is S dot B. The B attribute from my S relation has 100 distinct values. That is each value into the cell is a distinct value. So this is an example. So in that case, every value of B in S will match to a value of B in R. Okay, जेवढ्या जेवढ्या माझ्या व्हॅल्यू R मधल्या ज्या आहेत त्या प्रत्येकासोबत मॅचिंग झालं S च, and because of which there will be 100 tuples into the output. Next, S dot B has one values and this values match to R dot B. Okay, there is only single matching, म्हणजे एकच व्हॅल्यू आहे सेकंड रिलेशन मध्ये की जी मॅच होती. So in that case also here, this one is everywhere, but D's value will be different, because of which again we fulfill the constraint of primary key. So if consider a single value is matching with the only one value from the R relation, then I can say that here as matching is done for the common attribute. So again, I will have 100 records into the output. Okay, in this case, every possible value of B in S will have match value of B in R. So natural join will have 100 tuples here as well. Next, third case, S dot B has 100 distinct values and none of these values matches to R dot B. So here there is no matching. So it means that consider that in the R, I'm having value from 1 to 200, and in case of B, I'm having values from 201 up to 300. Then I guess that there is no matching for the common attributes, because of which we can say that the natural join will have 0 tuples. And another one is S dot B has one value and it does not match with the R dot B. So in that case, the value of B in S will have matched to a value of B in R. So natural join will have 0 points. 0 tuples. So maximum number of tuples will be 100 and minimum will be 0. So here, if explicitly mentioned that S dot B is a foreign key from R dot B, then case 3, that is not possible, because here it means a different set of values will be there, and because of which we cannot control that whether we should go for this comparison or not. Okay, and so these will be the output 0 and 100, and So here, even though if I don't have the matching value for 300, it means a single value is there which is not matching. Again, there will be zero number of the tuples will be there. So this is how it means we can have minimum number as 0 and maximum number of the tuples will be 100. So this will be the output of my natural join. So now let us go for the next example. Is anyone is having doubt regarding the previous problem? If so, please let me know. Okay, so now let us go for the next example. So next example is regarding relational algebra. So let R and S be relational schemas such that R is having A, B, C as 3 attributes and S is having only single attribute, that is C. Now consider the following questions on the database. So these are the four options are there, that is first, second, third and fourth. So the question is that which of the above two queries will be equivalent? Okay, between 1 to 4, which two are equivalent? That is the question. So let us read this question carefully. Take a minute and let me know the answer. Out of A, B, C, which one is correct? Any answer? I cannot see any answer into a chat window. So, okay, let us go for one by one. So first question, that is pi of R minus S, that is we are taking from the R minus pi of R minus S in bracket pi of R minus S from the R cross product with the S minus pi minus R minus R minus S comma S, and from the R we are taking. Okay, so it means that here first we are taking, that is which attributes will be there into the end. Okay, and which can be the attributes into the second, third and fourth. So here this is a record, that is a query from the all the domains, that is relational algebra, tuple relational calculus and SQL. So SQL, this is a combination of procedural and non-procedural, which is based on the relational algebra, but still combines tuple and domain relational calculus. And that's why this SQL is called as a non-procedural query language as well. So let us go for one by one. So first, let us take which will be the attributes into the first relation or first output or first query. Okay. So, okay, the first relation says that R equal to ABC and S equal to C. Now consider the following queries on the database. So it means that here R is having R equal to ABC I'm having and S equal to C I'm having. It means these are the attributes of the first and second relation. So whenever I'm saying pi, okay, pi R minus S, okay, R minus S, it means that here I'm combining the attributes of R minus the attributes of C, attributes of S. So it means that I'm performing ABC minus C, because of which I will get only A and B. Okay. So A and B will be the attributes in the R minus S. And this we are taking from the R. Okay, R, from the R we are taking these two attributes. As S does not contain these attributes, then it definitely means that we are taking these attributes. So AB will be the first output of this one, that is pi R minus R. So first clause, that is first subpart, get calculated. So I will name this as a first. Then next, second says that pi of R minus S. But before that, we are having a bracket. So let us solve the first bracket. So within the bracket, the first part is regarding pi of R minus S. So it means that the same part we are needing. So again, for this purpose, we need to perform the initial calculation. So AB, from the AB, the first part, cross product with the S, that is C, minus here pi of R minus S. Okay, R minus S, again I will get the same records. Okay, so in the pi of R minus S, so this part is this part, that is this part is this part. Yes, contains only single attribute, minus pi of R minus S. So here again I will get AB, comma C. Comma C, it means that again I will add the C attribute. So cross product will lead to the combination of all the records. Okay, so all the relations will be there. So it means that all the attributes will be there. So ABC minus ABC, again here my every what we can say. So this is my one relation and this is my another relation. So within that, even though if I'm taking the ABC as my output, so this will not give me, here it will give me the complete relation. But whenever I'm talking about the cross product may give me the more than one relations combined. So here from this, if I'm deducting this, this will again lead to the records from S which are there available, and from that we are taking only pi of R minus 1. So here I will say that cross product of these two minus those records which are which will be deducted, and after the deduction I will get only those records which are available into the first R as well. Okay, so here I will get only single R. So from that R, again I am needing these two attributes, that is which are from the first relation. So here I cannot give this output in terms of what we can say, in terms of attributes only. So let us check which are the other outputs. So here I can say that the initial I will get only two records, A and B. So here I may get to A and B, but this will have a separate set of the tuples. So now let us go for the second. Second says that T belongs to the R minus S of R. So yes, this condition as this condition is same. And there exists a U. Okay, there exists a U which belongs to S. Okay, where for all V belongs to R. Now we are running into this. V U equal to V of S. Yes, again, we are talking about the attribute. So attribute C will be there and T equal to R of minus E. Yes. So can anybody? And V, which belongs to R. So here the difference between first, second, and third option is that the tuple belongs to yes relation and the tuple belongs to the R relation. So can we say that these two are same? No, we cannot say that because here the yes is having a different structure and R is having a different structure. And we cannot set this condition. It means that second and third are not equal. So I'm having much more doubt that the first and second are same, but let us see which other option can also lead to the same answer. Select R dot A. Yes, I have selected from R. I have selected R, A and B. R dot B from R comma S. So here again, we are going for the cross product and where R dot C equal to yes dot C. So again, we are sure that this relation or this equation is at all not equal to the first or second or third. Okay, so here this is simply a natural join and displays only those attributes which are from the R. But as we can see here, the deduction of contents which are equivalent, that is done. And hence I can say that the fourth is also not equal to the third, second, or first. So I can say that 2 and 3 are not equal. Okay. Next, 1 and 2 are not equal. 1 and 2 are not equal because here whatever the R we are taking, so here again we are taking the condition that R minus S is there. But this V belongs to the R. Whereas I'm taking the cross product with the R and everywhere I can say that yes is the second into the relation. And that's why I can say that the first and 2 are matching. Okay. So here I will say, let us see the option 1 and 2, 1 and 3. 1 and 3 is not available. 2 and 4 are at all not equal because this at all equation doesn't give me a feel of natural join. 3 and 4. So 3 and 4 is also not equal because this equation and this equation at all not responsible for natural join. 1 and 3, no, we cannot guess this. 2 and 4, no, because natural join is not shown by this. So 4 I'm eliminating from the options because 4 says that natural join and natural join is not shown by any of the relation. That's why wherever 4 are there, that options I will remove. Remain with the first and second option. So let us take the first option. So here I can say that this is a possibility that we are having the combination of attributes seen as that of this and this. And the third says that this V belongs to the R, which is at all not possible with the combining this equation with this. And hence I can say that the option A is correct. So this guess we can apply into the normal examinations. So next, these are the operators from the SQL query. SQL query, we can perform the multiple operations just like select, from, where, exist, group by, order by, aggregate functions and nested queries. So let us see for which purpose the select clause is used. So select clause is used for having the common columns, that is a display which need to be displayed for the output. So this select is different from that of the relational algebra select. In case of relational algebra select, that is sigma symbol is used for selecting the rows or applying some predicate or applying some condition on my records. Whereas here the select clause is used for giving the selecting the columns or filtering the columns. Okay, next from clause. So from clause is used for displaying or listing the rows on which the predicate and select clause is based. Where clause is used for passing some conditions or filtering the tuples. Exist, this is also keyword which will check whether the output of query exists or not. That is, the query result is empty or not. So it doesn't guarantee whether how many tuples will be there, how many records will be there, how many columns will be there. No, exist will only check for the emptiness, whether the output of query is there or not. Next, group by. So group by clause is used for grouping the tuples based on some attribute. So attribute, this will count that, just like if you wanted to count how many of the given records are having same value, that is wherever matching value will be there, those will be listed into single group. Just like department wise count of the staff, department wise count of the students, department wise students crossing 80, department wise student crossing 60, etc. It means group by clause is used for counting the single attribute values per, it means based on the common values. Then order by, wherever we wanted to sort the elements of display in ascending as well as in descending order. Aggregate functions, these are used in order to combine the results wherever multiple values are there. For example, there are 5 aggregate functions are there: count, sum, mean, max, and average. Okay, so these are the 5 aggregate functions available. So out of that, average and sum, these two are applied on the numeric data, whereas mean, max, count, these can be applied on the alphabetical data as well, finding the minimum value, finding the maximum value, or finding the count of the values. Okay. Next, nested queries, where nested queries, it means that one query can be part of some another query. Okay, so this nested queries contains 2 parts, that is outer query and inner query. So inner query will be also called as a sub query. Okay, so sub query is always a select query, whereas outer query can be anything, just like any DDL statement, creating a table, any select query, any insert, update, or delete, any query can be outer query, but inner query is always a nested query, where we are defining query within a query. So here is a question for you. So consider there are 3 tables are there, A, B, C. So how many tuples does the result of the following SQL query will have? Okay. So tables are there. Table A is there. ID, name, age. Table B, ID, name, age. Table C, ID, phone, and area. Okay. So query is given. Select A.id from A, where A.age age less than all. Select B.age from B, where B name equal to Arun. And the options are given as well: 4, 3, 0, and 1. So let me know the answer of this question. Please go through the question carefully and let me know the answer. Okay, solved with the question. Clear with the question? Anybody able to answer the question? Okay, so whenever we are talking about the nested query, always the inner query or sub query gets executed first. And based on that, the output of the outer query will be decided. So let us see what will be the output of our inner query. Select B dot age. Okay, select B dot age. That is from the table B. We are going to select the age column. So from B, so complete B will be taken where B dot name equal to Arun. So let us see whether anywhere the name contains the Arun values. So I can see Shreya, Hari, Rohit and Rohit. Nowhere I can find the Arun value. It means that B dot name equal to Arun. This condition is satisfied for 0 number of the tuples. And hence B dot age will be null value. Null value, it means that it will not return, it will return a empty set. Empty set. So here, this less than all condition, greater than all condition is there. So let me tell you what is difference between normal greater than and all greater than. Okay. So if consider I'm using this symbol directly, it means that here I'm having value 1. Okay. And here I'm having value 2. Okay. So it clearly says that value 1 is greater than the value 2. But when we are talking about in terms of SQL, so here whatever comparison I am performing value 1 less than, and here I'm having the output of the subquery. Okay, so subquery, this always gives me, it can give me a single value or it can give me the मल्टिपल व्हॅल्यूज. म्हणजे असं नाही की सब क्वेरीचा रिझल्ट एकच असेल, माझ्याकडे सब क्वेरीचे रिझल्ट भरपूर असू शकतात. सो हियर it means I may have number of the values. Okay, so but what about this operator? Or consider here I'm having 9 and here I'm having 7, and consider here value 1 I'm having this as a 10. So I can say that 10 value is greater than 12. So first result will be false, second result will be false, third result will be true, and fourth result will be true. So 9, 7. For this, the condition got satisfied, and but for the 11 and 12, this condition did not satisfy. So it means that whether I should say the overall result is true or false. So that is not decided. So this condition unable to decide whether we should decide the result of this operation, whether it's true or false. Okay, and for this purpose we are having the operator here, all, some. Okay, so all it means that whatever this condition is there, that should be satisfied for the all the elements into my set. Okay, म्हणजे ही जी कंडिशन आहे ती माझ्या सगळ्याच्या सगळ्या एलिमेंट साठी सॅटिस्फाय व्हायला हवी. Okay, so if consider here all true are there, then only I can say that this one is true. Okay, else this condition will be false in case of all. But whereas if I'm using some operator here, some operator, it means that if this condition got satisfied for at least single value, म्हणजे एका सोबत एका एलिमेंट सोबत जरी ही कंडिशन सॅटिस्फाय झाली तरी सुद्धा त्या केसेस मध्ये this will give me the true as an output. Okay, so in the query we are having all here, all it means that जे काय माझे आउटपुट आहे या टपलचं, along with that compare this greater than condition with the age, but this should be satisfied for all the attributes. But as we can see that this is an empty value, so it means that a dot age anywhere I'm going at this point, this age will be greater. म्हणजे कुठलं का एज चेक करे ना ते नेहमी ग्रेटरच असेल, कारण की याची जी व्हॅल्यू आहे ती मला एक एम्प्टी सेट मिळाली. इट मीन्स दॅट दिस व्हॅल्यू इज नल, म्हणजे ती व्हॅल्यू एक्झिस्ट करत नाही. अँड हेन्स this condition will be satisfied for this age and this age, and hence number of records. So select id from a where a dot age is greater than all, so this condition will be satisfied for the every age from my a, and hence the number of records, how many tuples does the result of the following query contain. So I will have 3 tuples into the output. So I'm having the options 4, 3, 3, 0, and 1. And it means that for 3 tuples, my condition will get satisfied. Okay. So this is how we are solving the question. So now let us go for the next question. Next question is regarding this. So actually this one is much more lengthier question. So that's why I will enlarge the value. Sorry, enlarge the presentation. Let us read a question. Consider a database containing a database table T containing 2 columns X and Y, each of type integer. Okay, there is a database and within that I am having table and which is having 2 columns X and Y. After creation of the table, one record X equal to 1 and Y equal to 1 is inserted in the table. Let mx and my denote the respective maximum values of x and y. Okay, table got created, we inserted record, and mx and my gives the maximum values in respect of x and y among all the records in table at any point in time. म्हणजे कुठल्याही वेळेला जर mx आणि my जर असेल तर ते माझे मॅक्स व्हॅल्यूज आहेत त्या कॉलमच्या. Using mx and my, new records are inserted in the table 128 times with the xy values. Okay, म्हणजे मॅक्स व्हॅल्यू जी आहे x आणि y ची त्याच्या बेसिसवर काय केलं की माझे व्हॅल्यूज इन्सर्ट केल्या. किती वेळा inserted in table 128 times with x and y values being mx plus 1, 2 star, my plus 1 respectively. Okay, so it means that initially if I was having, okay, so this is my x value and this is my y value. Initially I given the value as 1 and initially the value will be 1, but here I'm maintaining a concept of mx and I'm maintaining the concept of my, which gives me a maximum value. Right now, if single record is inserted, 1. So, mx formula, we are having this as a, initially this will be 1 and this will be also 1 max value. But whenever I'm trying to insert the new record, naveen record insert karaycha hai, then I'm having this formula as mx plus 1, mx plus 1, x ला insert करण्यासाठी formula आहे, and y is having the formula 2 star my plus 1. Okay, this is the formula for the inserting y. Then it means that if I'm having mx is 1, the next value of x will be inserted will be 2. That is 1 into 1 plus 1, that is 2 value. And for the y, 2 multiplied by my, 2 multiplied by 1, 2 multiplied by 1, that is as per this formula, 2 multiplied by 1 plus 1. So 2 into 1, 2 plus 1, 3. Okay, so this value will be inserted. Then max will have value 2 and this will have value 3. Then again same formula and same record inserted. Such 180 times the value was inserted. Okay, so it may be noted that each time after the insertion, values of mx and my change. Of course, these are representing the max values. It means that after each insertion, I will have the change in the value. What will be the output of following SQL query after the steps mentioned above are carried out? Select y from table T where x equal to 7. Okay, माझ्याकडे x ची व्हॅल्यू जर 7 असेल 128 times आपण insertion केलेला आहे. And I wanted to check what will be the y whenever I'm inserting x equal to 7. So how we can solve this question? 7 times, okay. Any answer? I will not give the suggestion first. Let me give you a minute for thinking. Now calculate with the value. So how we can calculate? Okay, take a minute for this. So anybody calculate the result? You can answer into chat window. Okay, have you studied about arithmetic progression where the number grows with the formula, etc.? So okay, I am also right now not clear with the formula, but at it means by learning the arithmetic progression, you can directly go to the that nth number of the series directly. Okay, but right now, as we are having, it means right now we are learning this. So let us see how we can calculate the value. So each time for the max, I'm using the same formula, that is whatever the max value of my x will be there. And here in the question, I'm having series up to x equal to 7 only. So I will choose to decide serial. It means serial means that arithmetic progressions formula. So we will go for the serial. So it means that here I will have 3 value of x. So the formula says that for calculating the y value, 2 star my plus 1. So 3 into 2, 6, 6 plus 1, 7 will be there. Then 4, 7 multiplied by 2, 14, 14 plus 1, 15. Then 5, okay, 5, 15, into 2, 30, 30 plus 1, 31. Then 6, then 30, 31 into 2, 62, 62 plus 1, 63. And then 7 will be there. So 63 multiplied by 2, 126, 126 plus 1, 127. So here select y from t where x equal to 7. So x equal to, whenever x equal to 7 will be there, I will have 127 as my y. So let us check within the options. I'm having a equal to 127. So it means that I can say that this will be my answer here. So if directly I'm getting the answer, directly I can say a equal to 127. This will be the y from my answers. So clear with this? Okay, so now let us go for the next example. So this one is example, database table by the name loan records is there. So loan records, so borrower, bank manager and loan amount. Okay, what is the output of the SQL query? Select count star from. So in the from, I'm having select borrower, bank manager from loan records as yes. So here I can select there is a query into my from clause. Okay. Within the from clause, I'm having subquery here, and subquery, as whenever we are writing into the from clause, always we need to give the name analysis. Name analysis, it means that whatever the output of this query will be there, that will be preserved into this alias during the query execution. So S will be my first relation as an input, and second relation will be T. And within that, I wanted to perform the natural join. So calculate the question and answer, and let me know the result. Okay, here we are having two subqueries as part of our from class. Select borrower and bank manager from loan record. So first two columns have selected it into the first query, and that will be called as a yes. So this is a unconditional selection. Unconditional selection, I can say that every record, as there is no condition, that is anywhere I can't see the where clause, it means that every tuple, there are three tuples, those tuples will become my part of S with two columns, borrower and bank manager. And next, select query, another select query for the natural join input, bank manager and loan amount. So this again from loan records. So again, here also, I don't have any condition. So it means unconditionally, these two records, sorry, these three records with two columns will be get selected. And then I am performing the natural join. So if I'm performing the natural join, so how many tuples will be there into the output? Okay, so count star, it means that how many tuples are there into this from clause or the output of this from complete clause. What relation it gives as the output, that will be the output of our query. So here, if I'm saying that it is selecting the first two columns and the second query also select the first two columns. So in that case, we will, it means that the first natural join, it means that the bank manager, this field will come first, then the attributes of the second column and attributes of the third column. Okay, that is a second relation remaining attributes. So within that, this is a part of my first query. Okay, this is the part of my first query. First subquery, this is my S, and this is my T. Okay, so let me know how many tuples will be there into the output. So I will copy this into some another slide. So that we can perform the natural join. So natural join says that we should go for the common columns between the both relations. So I can see that there is a common column between these two relations. So it means that this column will be the first part, then the attributes of my first relation and remaining attributes of my second relation. So bank manager, I will go for. Okay. So this will be my output. Sorry, output 8 we had not decided. Okay. So first tuple, we will go for the matching. Sundarjan and Sundarjan. It means this is a matching. So natural join says that whatever the common attributes are there, for this purpose, we should have a matching. Right now, this field is common between the both the relations. It means that we should go for matching value of this attribute. So Sundarjan, this was the matching value. So I will copy this value. Then equivalent value we are having as a Ramesh for borrower and 10,000 from the loan amount. Done. The first matching is done. Now this tuple we matching with the every other tuple from the second relation. So Sundarjan and Ram Gopal no matching, and Sundarjan matching here. It means that again we got the same person with also bank manager. In the first tuple is also bank manager at this here also. So it means again Ramesh will here, and here I will have the different loan amount. Done. Now again Suresh, Ram Gopal. So this matching with the every other tuple is done. So this tuple we hide here. This tuple matching we had at this point. So now we will have a Ram Gopal as our bank manager. Ram Gopal matching with the Sundarjan. No, at this point matching is there. So matching is there, it means that the output will be collected. And for this, I'm having 5,000 as my amount. Sorry. Okay, no problem. Then Sundarjan matching with this Sundarjan and Sundarjan matching with this. Again, it means that I will have repetition of the same value twice. So Sundarjan, Ramesh and Mahesh. So Mahesh combination was remaining. And this combination we should have for the everyone. Done. So this will be total 5 tuples will be there. So question, count. So I will count and this will go for result as a 5 here. Let me know if you are having the problem in this. Okay, no problem with this. So now let us go for the next problem. So here we go for the next problem. So let me read the problem, read the question and let me know the answer. Okay, any answers for this query? So okay, here into the first table, that is this table, we are having roll number as a primary key as per this instruction, and into the second, roll number and subject code. It means this combinedly forms my primary key. It means students marks and subject code. Sorry, for each student only single subject code is there, and that's why even subject code is repeated, this combination, the complete two rows combination will not get repeated. So it means that for each student the marks are given here, the marks are given, and because of which this complete combination will not get repeated. This combination is unique throughout my relation. The query says that consider the SQL query given below. Select, okay, before going to the select, let us go for the from. So here we don't have any concept of nested query, but we are having group by and aggregate functions. And because of which, let us try to solve this query. From student yes, that is this complete yes, and performance P. Okay, so here the rename is done. So complete yes is referring to the student table and P is referring to the performance table. So here we are filtering the records by using a where clause, and the condition is that P dot marks should be greater than 84. Okay, so out of this 84, I can say that only this tuple is not qualified here. Okay, this tuple will not be there. Remaining all tuples, the matching will be there. So here the question comes, which tuples can be there into the output? So as here in the from clause, we are having student yes and performance P. But in between the natural join concept is not there. So it means that by default, this operation is nothing but a star. Star, it means that this is a cross product. Cross product, it means that the first five or every record of my first relation will be get mapped with the every other record of my second relation as well. Okay, and because of this, I will have multiple records into my SQL query, just like yes dot roll number, then yes dot name, okay. Instead of this, I will go for here. I will take a new slide, and into the new output, that is the this output. Here, whenever I'm saying student yes and performance P, this will give me a cross product. Because of the cross product, every value from the every column from this and every column from this will be get listed. And because of which, here 2 columns and 3 columns, I will have total 5 columns in the output. So I will go for the table. I will have 5 columns, and let us take rows 5 only. Okay. So first 2 columns, roll number and student name will be there from the first relation of my query. So here right now we are solving the query only, and remaining 3 will be roll number, student code, and marks. So here every other column is unique, but simply this roll number is repetitive. So I will name this as a yes dot P, and here I will use as a P dot roll number. So it means this yes is from the students and this P is from the performance. So Cartesian product or cross product, it means that every tuple from my first relation will be get mapped with the every other tuple of my second relation. Okay, so it means that that's why here I will take this 5 records, and here I'm having total 6 records. 6 into 5, there will be total 30 records will be there. 30 records that this, okay, I will take only single record, one Amit. This mapping with the every other record from my relation. Okay. Okay, this will have matching with the this 3C80 also, but in the query we have applied the where clause and p dot mark should be greater than 84. So 84 out of this complete, only this is a record where this condition is not satisfying. So this will be filtered out. That's why I have already removed this. So similarly, we will have along with the 5 Smita. So I will use a triple dot here to 5 Smita. And repetition of the same records. Okay, so can you imagine the output now? Here, these are the records from the first relation and these are the records from the second relation. So Cartesian product we are performing. So then group by S dot name. Group by S dot name, it means that every name will be taken as a single entity, and grouping, it means that this value will be also grouped and this value will be also grouped. It means for the student Amit, I will have only one record and Smita, and similarly for the every other name also I will have only single record. Okay, so I will copy these names. So in between I will copy this. So Amit got repeated. So let us remove this. Yes, these are the total grouping will be there. So grouping is done. Then next, yes dot name and sum of p dot marks. Here we wanted to calculate, perform the counting of the marks. Okay, I have done counting based on the marks. So Amit, for the Amit, I'm having these many records. So फक्त एका recordचं calculate करूया and based on that we will go for the repetition of the records from the remaining records. म्हणजे बाकीच्या नावांसाठी पण same procedure आपण follow करूया. Okay, this is the actual record, that is की म्हणजे एक टप्पल कार्टेशियन प्रोडक्टचं प्रत्येकासोबत मॅप होतं. So if I am performing the grouping, it means that this complete will be taken as a single group. आणि सिंगल ग्रुप केल्यानंतर मी ह्या मार्क्सचं कंबाइनिंग केलेलं आहे. So let us calculate the sum. So here I will be combining, these marks will be combined. So how much will be there? 13. Okay. Why I should calculate when I am having all the tools with me? Sorry, 452. So this counting is 452 will be there. So this will be the counting simply available for the Amit only. Okay, Amit सोबतच ती counting असेल कारण की ही अमितच्या मार्कांची बेरीज आहे. Irrespective, here it is not checking whether this marks belongs to Amit or not. It is only checking whether I'm student name is there. For this purpose, grouping will be done, and on the each group, the criteria will be applied. So if consider, I'm saying that here it says group by student dot name. Yes, we have performed the grouping and we are performing the sum p dot marks. म्हणजे प्रत्येक नावासोबत फक्त p dot marks जे आहेत त्यांचं सम डिस्प्ले व्हावं. So how many records will be there? So any idea? म्हणजे या क्वेरी मधून म्हणजे या आउटपुट मधून तुम्हाला कळेल की बाबा आउटपुट किती आहे. So how many records will be there? Any guess? So here I am having Amit, Priya, Vineet, Rohan and Smita. Total 5 students are there. It means group by 5 names will be there. 5 names and 5 sum of p of marks will be there, and hence I can say that the number of rows written by the SQL query will be 5. Okay, clear with this? Okay, so it's right now 2:56. So let me have the queries if you are having any, or else we will stop here. Next 5 minutes. Let me know the queries and let me take the attendance simultaneously. I'm still on. Let me know the queries if you are having any queries. Okay, I'm done.